Hello everyone, today I would like to talk about exceptions. Exceptions in programming are a way to handle unexpected events during the regular flow of a program. So to demonstrate this, let's look at an example. And to start, let's create a class called mathematics. And inside the class we create a public static method called divide that returns a floating point result, and we divide integer a by integer b. So we return a divided by b, and we cast b to float so that we perform floating point division. Now, calling this method, what could possibly go wrong? What is an unexpected event here? What could occur is that b is 0. In that case, we would perform division by 0, which we really don't want. At the best case, it could be a value close to infinity. At the worst case, the program could crash. So we check here first if b is 0, and the most primitive way to handle this would be we output a message cannot divide by 0, and we return maybe 0, some default value. Now if we go and create a main, so I create a class main, add the main method, and then I read two values in from the console. I import the scanner, I create value A and value B, and then I pass both values to my divide function of the mathematics class. And finally, I output the result. So if I call this method and I would pass in 5 and 0, for example, I would get 0 because this is the special case here of an unexpected event where b is 0. However, if I go back to the main and I pass in 0 and 10, I would also get 0. So in that case, I have no way to distinguish these two values. I don't know if an error occurred or not. And this is really where exceptions in Java come into place. Now, all exceptions in Java inherit from a base class called exception. And the exception that we create, they will always be thrown and they will always be caught. Now, we only talk about checked exceptions here. There are another type of exceptions that inherit from runtime exceptions and that are unchecked. So checked exceptions are checked by the compiler during compile time. So let's start by creating a exception class. We call it divide by 0 exception. Typically, we give it a meaningful name with the exception suffix. And like I said, all exceptions inherit from the java.lang exception class. So we select this and we generate this. This is all we need for the exception. We have our class name and we extend the exception superclass. Now we go back to our mathematics class. Here we have the divide function, and now we have a checked exception. So the first thing that we have to do is tell the compiler what exception may be thrown by our class. We do this by adding the throws keyword to our method signature, followed by the exception type that may be thrown. So in this case, divide by 0 exception. If this method may throw more than one type of exception, we could add additional class here with comma, and then here another exception. And we could have comma and even more. So in this case though, we only have a single exception that may be thrown, which is the divide by 0 exception. So let's get rid of the system.printout and the return block and actually throw an exception. So we use the throw keyword without an s, and the throw keyword is always followed by an object that is thrown. Now in this case, we want to throw an object of the divide by 0 exception. And so we have to create it by calling the constructor new, and then we call the default constructor that creates the exception object, and the throw will throw it. So we go back to the main, we see an error message here now, and this says unhandled exception type divide by 0 exception. That means the compiler notices that this method has a throws keyword and may throw an exception, and we have not handled it. So the way to handle it is adding the try keyword and with a catch block. So this is the try catch block here. We have the catch statement, and here we can actually catch the exception. And then we can handle it. The most basic way and common way is just output the stack trace, but we could really program anything here that we would like to. Now if we run this, and let's say we enter 5 and 0, we can see the method got called, it threw an exception, we caught it, and we outputted the stack trace. So the stack trace will help us where the main is and where the exception was thrown. Now this is for a single type of exception that got caught here. We didn't really catch, or we didn't really output a specific message. So we could do that by adding a customized constructor. So we do public divide by 0 exception, we pass in a message. We pass that message to the super constructor, and now we can add, when we create the object, we can add a customized message here. Cannot divide by 0 in, I pass in the values, in A divide by B, B is 0. And now if I go back to my main and run this, and I enter 5 and 0, I get the customized message here. Cannot divide by 0 and 5 divided by 0. So this is a powerful way of adding some customized message. We can also track the state. We could pass in here additional values or objects, whatever your situation needs. And we could pass that in and store it in member variables. And then whenever we catch it, I go back to the main, I could access them here. Maybe get A, get B, or I could also get the message with .get message. So then I have access to everything if I need to do additional processing. Now this was for a single exception. If there are other types of exceptions that we expect, we could add additional catch blocks. For example, if we would expect a null pointer exception, we could handle it here and output the stack trace. Or if we always handle it the same way, we could also use the binary OR operator and just list the exception classes here. So this would be one way. So there are multiple ways to catch additional exceptions. Another important thing is we could add a finally clause, and this allows us to execute code even if an exception was thrown that is not caught here. So if anything else gets thrown, finally will always be executed. This is good if we have a connection to a file and we need to close the file or the file stream, or we need to close and clean up the database connection. This is where finally is really good. So this was some basic introduction to checked exceptions. Thank you for watching, and see you next time.